having with UDay. In this video, we will discuss about queue data structure and the operations we can perform on queue data structure. So without any further delay, let us get started. Queue is a linear data structure, just similar to the stack data structure, which we discussed in the previous video, and it stores values in a continuous fashion. Because queue data structure also belongs to linear data structures, which is similar to the stack ADT. And queue follows a strategy called first in first out or last in last out strategy. And queue is represented in horizontal fashion, just like this. And to insert or delete any values in queue, we will be using a pointer called front and rear. And the word first in first out or last in last out mean the first inserted element will be the first deleting value from the queue, and the last inserting element will be the last deleting element from the queue. What I mean by that is, let us look into this picture and understand from it. So here I would like to insert a value 10 first. So what I do is I insert 10 by incrementing the rear position, and I insert the value 10. And if I have to insert one more value 20, I first increment rear position and then insert value 20. And if I'd like to insert one more value 30, I would like to increment rear position first and then insert the value. And suppose if I'd like to delete it, here I am not incrementing or decrementing rear position like in stack. Here I will be using a pointer called front, and using front pointing variable I'll be able to delete the values from queue. Here you can see that 10 is the first inserting value, and if I'd like to delete any number from the queue, 10 will be the first value to get deleted. Similarly, I can also delete 20, which will be the next deleting value. Now we'll discuss about terminology of queue. In queue, when we talk about queue, there are certain things which we discuss or we name particularly, and those things are front, as we seen previous or before. So front is a variable used to perform delete operations on queue, and rear is a variable just similar to front variable. It is used to perform insertion operation. So here front is a variable used for deletion operations and rear for the insertion operations. And the default values for front or rear will be -1, just similar to stack, because in the array the index numbering start from 0. And what I mean by that is, so here you can see that I have taken an empty queue where there are no any values in the queue, and using front and rear I'll be able to insert values into the queue. So here I would like to insert a value 10. So what I do is I use rear position or rear variable to make insertion operation. First I increment the rear position from -1 to 0, and then I'll be able to insert value 10 into our queue. Similarly, if I'd like to insert 20, I can do that using incrementing of rear variable and then inserting the value. You can see that I'm incrementing the rear position to 1 and then inserting value 20. Whereas coming to the deletion operation, I can perform that using the front variable. Here you can see that the front position has moved from -1 to 0. Now I'll be able to delete 10 from the queue. Similarly, I can also delete 20 by incrementing the front position. So now you can see that the front position changed from 0 to 1, and I can delete 20 from the queue. So this is how we use rear and front variables in queue. Now we will discuss about the terminology underflow. As we saw already in the stack data structure previous, so underflow is a state which represents that the queue is completely empty. And we all know that when the queue is empty, we cannot perform any delete operation on the queue. So let us see that pictorially. Here you can see that the queue is completely empty, and whereas the front position and rear position is -1. And also there are certain cases where you can see in the previous picture right here that the front and rear position are not -1, but they are pointing to the same index. Even this state also can be known as underflow state, because front and rear values are equal. We can also tell that when front equals to rear or rear equals to front, the queue is underflow. Hope you understood what underflow and when we can say that the queue is underflow. Now we will talk about overflow state, and it is a state that represents queue is completely full. And we know that when queue is full, we cannot insert any values in the queue. Let us see that pictorially. So you can see that here the queue is completely full, that we have 0th index 10 and we have first index 20 and then 30 and then 40. Here the rear position is pointing to index 3, which is the maximum index that a queue can have in this particular example. So this condition we use for checking the overflow state. The condition goes like this: when rear value is greater than or is equals to max minus 1, where max is the constant variable which we take to define the maximum number of elements we can store in a queue. Let us move ahead to the operations on queue. So here you can see that the operations that we can perform on queue is Enqueue. So Enqueue is an operation which is used to insert values into the queue, just like push operation in the stack. And coming to Dequeue, Dequeue is an operation which is used to delete values from the queue. And we have display operation which is used to display all the values from beginning to the end of the queue. And we have peek operation which displays the maximum or the most recently inserted value into the queue. That is like the topmost value in the queue. And lastly, we have count operation which is used to give us the available number of values that are there in the queue. Alright, so before we proceed to the operations on the queue explaining in detail, I have also uploaded a video on my channel. So if you are very bored and if you'd like to play a game or to solve a puzzle, you can go ahead and try this video. I'll share the link in the description, and you can just go ahead and try solving these puzzles. So here you have to guess the vegetable using these emojis. So like we have the first emoji, a lady, and we have second emoji, finger. So the vegetable name, I believe you would have guessed it. So please answer please comment your answers in the comment box below. We'll see how many of you can answer this puzzle. So we'll forward to the next slide. And now we will discuss about Enqueue operation. So Enqueue operation is used to perform insert a value into the queue. And there are certain steps to insert a value into the queue. So first we should check whether the queue is completely full or not, and also we tell that the queue is overflow. We check overflow with the help of this condition. If rear meets maximum minus 1 index, or when the rear value exceeds the maximum index, then we say that the queue is completely full. If this condition fails, only then we will be able to insert a value into the queue. But before we proceed with that, let us see the next step. So if the queue is not completely full, then we increment the rear position and then we can insert a value into the queue. So these are all the steps which we use for inserting a value into the queue. Let us see them pictorially now. We have this queue where it says that the queue is completely full because the rear is pointing to 3 or the third index, and the maximum that we can hold in this queue is 4 values, where we have 0, 1, 2 and 3. So here I am checking the condition rear, which we have 3 greater than or equals to, maximum is 4 and minus 1. So 3 greater than or equals to 3 condition satisfies, and now it displays overflow state. Let us consider a next case or situation. Here we have the queue which is completely empty. Now we will be able to perform insertion operation. And first let us consider a value which I'd like to insert into the queue. Let's say 10. So what I have to do is I have to first check the condition, and here the rear value is minus 1, which is not greater than or equals to max minus 1. So now we will increment the rear position by 1, and then we can insert the value into the queue. So let me increment the rear position by 1 now. Here I have changed the rear value from minus 1 to 0. Now I can insert q of rear equals to x, which is q of 0 equals to x, which is 10. Now I am inserting value 10. Let us consider one more value to insert. So 20. So now I would like to first check the overflow state, where rear value is 0 and 0 is greater than or equals to 3, which is not true. So now we can increment the rear position by 1. Let me increment it. And now I can insert the 20 into the queue, which is q of 1 equals to 20. Hope you understood the Enqueue operation. Let us do one more insertion operation, 30. First I check the overflow state, it is not overflow, I increment the rear position by 1, so from 1 to 2, and then I insert the value 30. So this is how we make Enqueue operation using these 2 steps. Hope you're clear with that. And I'm incrementing one more or inserting one more value 40. Increment the rear value and then insert the value 40 into the queue. So now you can see that the queue is completely full, and if I would like to insert one more value called 50, now it tells us that the queue is completely full and it is overflow, because rear is 3 and rear when 3 greater than or equals to 3 the condition fails, it comes out of this particular condition and it displays us telling that the queue is overflow. Overflow means the queue is completely full. Now we will talk about Dequeue operation. So Dequeue operation is a deletion operation which is used to delete values from the queue. And here there are 2 steps again. So first we will check for the underflow state of the queue, and we check underflow state of the queue using this condition. So when rear or the front meets rear position, then we say that the queue is completely empty. If not, we can print the value which is about to be deleted, and then we just simply do front plus plus. All right, we will see that pictorially how it is happening. So here we have a empty queue where you can see that front equals to rear. Now I can just go ahead and check the front equals to rear, and we are just simply printing that the queue is completely empty. Let us consider one more state. Here you can see that the rear position is pointing to 3 and the front position is pointing to -1. So here you can see that the front equals to rear. So front is not rear because front value is -1 before. Yeah, and then the rear is 3. So front is not equals to 3. So now we will be able to delete a value. I'm sorry, I made a mistake here. So it should be queue of front. I have typed queue of rear here. So hope you understood the mistake that I have highlighted, that I'm trying to highlight here. It should be print queue of front is deleted. Now I have to increment the front position, and then we can delete the value from the queue. So first I have to tell to the user which value is being deleted. So which is front plus plus, and then delete the value 10. Hope you understood the steps. Let us delete one more value. Here I would like to delete one more value. So since front is not rear, it is going to the second step, and it is telling that it is incrementing the front position by 1. So the front position has changed from 0 to 1, and now we will be able to delete 20. So this is how the Dequeue operation works. Hope you understood how this Dequeue operation is working. I am trying to delete one more value just to make you people understand. So now 30 will be deleted, and then if I try to delete the next value, it will get deleted because front is not rear. Now I'll be able to delete 40. If I try to delete one more value now, where it checks for the condition first, front equals to rear. Here the front is pointing to index 3 and also rear also pointing to index 3. So front equals to rear, then it is telling us that the queue is completely empty and it is in the underflow state. Hope you understood the Dequeue operation. Now we'll talk about display operation. So display operation is used to display all the values from beginning to the end in the queue. And this works in 2 steps. So first we should make sure that the queue is not empty, and only then we'll be able to display values in the queue. So here empty is checked by using the underflow condition. The underflow can be checked using this condition as we seen in the Dequeue operation. If this condition fails, then we can start from the front plus 1 index, and then we have to print all the values corresponding to every index till we meet the rear position. So let us see that pictorially now. So here you can see that the queue is completely empty, whereas front equals to rear. Now it is displaying that the queue is completely underflow. And if not, let us consider one more state. Here you can see that the front value is -1 and the rear value is 3. So now front is not equals to 3. Now we are starting with I equals to front plus 1, whereas I value is -1 plus 1, which is 0. So now the first value which is stored in I is 0. Now we are accessing the first index in the queue, and then we are printing queue of I, which is 10. Now the 10 gets displayed, and then it goes for the increment and decrement step in the for loop, and then the I value will become from 0 to 1. And now it displays the queue of I, which is 20. Then it goes for the increment operation of I from 1 to 2, and then it displays 30, and it goes to the third index, which is I++. So the I value becomes from 2 to 3, and it displays 40 now. And the increment of I happens again. So now the I value will be 4, and 4 less than or equals to 3, condition fails, so it comes out of the loop. So this is how we perform display operation. Hope you understood the display operation. Now we will talk about peek operation. So peek operation is used to display the topmost value in the queue or the most recently inserted value in the queue. Now we will see the steps which we use for doing the peek operation. So first we should make sure that the queue is not empty. We use the condition to check the underflow state. And if this condition fails, there are certain values in the queue, then we are accessing the topmost value. As we all know that the insertion operation happens using the rear position in the queue, and we are displaying the queue of rear is topmost value or the recently inserted value in the queue. Let us visualize them pictorially. Here you can see that the front equals to rear. That tells us that the queue is completely empty or it is in the underflow state. If this condition fails, then we will go ahead and visualize this. So here you can see that the front value is -1 and rear value is 3. So you can see that the front is not rear. Now we can display queue of rear is topmost value, which is queue of rear. Rear is pointing to third index and the third index value is 40. Now it displays us that 40 is the topmost value. Here you can see that the 40 is displayed on the top of the queue. Hope you understood the peek operation. Now let us see the last operation in the queue, which is count operation. Count is an operation which is used to display the number of values that are present in the queue. Now we will see the steps which are needed to do the count operation. First we should make sure that the queue is not underflow. We use this condition to check the underflow state. If this condition fails, then we will go ahead and make use of a for loop to count the number of values that are there in the queue. So here I have started from I equals to front plus 1, which is very similar to the display operation, and I am trying to travel till the rear position and accessing every single index in the queue by doing I++. And here I am making use of a variable called count, and count initially assigned to 0, and then I am incrementing the count variable by 1 every single time I increment the I variable. And lastly, after I am coming out of this for loop, I am printing the count variable values. Let us visualize them to understand. Here you can see that the queue is completely empty because front and rear positions are -1. Let us consider one more case. Here you can see that front equals to -1 and rear equals to 3. Now we will try going and executing this step 2. And first count is initialized to front plus 1, which is 0. Here you can see that the count variable will get incremented now, which is count plus plus. So count is 0 by default and it is incremented by 1. So count variable will become 1 now. And now it goes to count plus plus or I plus plus, and it is incrementing the count variable again. And again we will increment the I position and also the count variable. And we are incrementing the I position and also we will increment the count. So after this, the I variable will become 4 and 4 less than or equals to rear condition fails. So the count plus plus will not happen. The for loop will be terminated right here. And now we have the count variable which is holding value 4 in the count variable. So print 4 values gets executed right here. Hope you understood the count operation. So this is it for this video, guys. And if you like the content of this video, please do subscribe to my channel. And I can see that most of our viewers are not subscribing to the channel. So please do subscribe to the channel if you'd like to watch videos like this on programming and data structures particularly, because as a programmer every single person feels very comfortable in learning basics in any programming language, but whereas coming to data structures, that is where the most of the logic is getting built. And you all know that most of the top MNCs or most of the companies are focusing on data structures for their employees to be known, and it helps a lot in your interview process to clear the biggest companies and to crack the topmost packages in the present IT industry. So please do subscribe to the channel, and also I'll be posting videos on on different questions that can be expected in interviews in C programming and other programming languages too, where you can go ahead and answer you can comment your answers in the comment box by going through the video. So please do subscribe to the channel to watch those videos and also to solve puzzles which you have seen, that you can go ahead and have fun by solving puzzles like guessing the vegetable. I'll be sharing the link to that video in the description box. You can just go ahead and watch that video and give your answers there too. If you like the content of this video, please do like our video and do share this video if you feel this video is worthy, and if your friends would like to be benefited from this for understanding the data structures and the details of programming language and also how to build logic with me. So this is UDay. Thank you so much for watching the video. Have a wonderful day ahead. Thank you so much.